Product or multiplication of matrices. Product of matrices. Matrices. This is the most confusing operation. So, for example, matrix A has m by n size. Matrix B has, for example, n by k element size. So here we have size of matrix A, size of matrix B. If you want to multiply them, A times B gives new matrix C. So if you put here sizes of these matrices, the matrix of C is, you have to take these two kind of boundaries numbers, m by k matrix, and each element of matrix C I denote like Cij equal. You have to take elements at the I row for the matrix A. I put here new L index times B L, and take from the column J and make summation along L index from L equal 1 to what? To n. This is the formula. Now I think that this definition doesn't sound very clear, and that's why it's better to make some examples here. Example. So, by the way, I didn't say it, didn't point out, this internal part and they have to be the same, the equal. Only then we can multiply. If you have here other numbers, not the same one, it is impossible to multiply them. For example, now I want to explain some examples. For example, A equal 1, 2, 3 elements. So this matrix has 3 rows and 1 column, and B matrix is the inversed kind of matrix, inversed matrix to the A. So it has, for example, 4, 5 is a row matrix. So A is a column matrix, B is a row matrix. For example, 6. So you can notice that this matrix is 1 by 3, 1 row, 3 columns. According to this rule, matrix C, which is product A times B. Now the first one step here, we have to define the size of the C matrix. If A it is 3 by 1 matrix and B 1 by 3, we can say that C matrix, we can use these 3 and 3, the boundary numbers. Matrix C is size 3 by 3. So it has 9 elements. I can denote C like C11, C12, C13, C21, C22, C23, C31, C32, C33. So all elements here. So for example, I want to calculate C11. So I have to take the first row for matrix B and first column of the matrix C. So it is 1, 1, 1. First column 4. Okay. C12, first row 1, second column 1 times 5. C13, first row, third column 1/6. Next one, second row, first column 2 times 4, 2 times 5, 2 times 6. And the last one, 3 times 4, 3 times 5, 3 times 6. And result of this multiplication is 4, 5, 6, 8, 10, 12, 12, 15, 18. This is the new matrix. Example. So if A equal 1, 2, 3, the same as is in previous one example, and B equal 4, 5, 6. Now I want to calculate matrix D, which is B times A. At the first glance they have the same situation, but the result will be absolutely different, far cry from the previous one. If B has size 1/3 and B and A matrix 3 rows and 1 column, the result of this multiplication is 1/1 matrix, so it's just one number here. I denote like D11. To calculate D11, we have to take elements from the first column and multiply correspondingly to the elements of the first row of the element B. So it is 1 times 4, AY11 times B11 plus A1, and switch each element of each second element of the each elements of the entries of the matrix. B21, A13, B31, and finally we have one times 4 plus 2 times 5 plus 3 times 6, and it is 4 plus 10 plus 18, and finally we have 32. So a result of this product is 1/1 matrix with one entry, which is equal 32. Let's calculate also one example. Matrix A equal, for example, 1, 2, 3, 4, and matrix B equal, for example, 5, 0, 6, 7. Okay. And I want to, this matrix is 2 by 2 matrix, 2 rows, 2 columns. Here we have 2 by 2 matrix, and result of their multiplication, C equal A times B. You can notice that it is 2 by 2 matrix. I put here 2 by 2 and 2 by 2. So it's clear that we can multiply them because we have internal numbers 2 and 2, they are equal, and the size of the matrix, new matrix C, is 2 by 2. Now we are ready to calculate this. C equal A times B, and it is 1, 2, 3, 4 times 5, 0, 6, 7. I want to use, for example, red ink here, and we have, I have to take, I put here C11, C12, C21, C23, or 22, also them 2, double 2, and we have, if I want to calculate C11, I have to take elements from the first column, third row, this is one, and first column of the second matrix, and then I have to replace the second one index from 1 to 2 because we have 2 just elements. So, and theorem. So 1 I have to multiply by 5 and 2 by 6, and I have 1 times 5 plus 6 times 2. If I want to calculate this element C21, I have to take the second, I used here I want to use this green ink. If I want to calculate this element C21, I have to take the second row and the first column, and I have 3 times 5 plus 4 times 6. C12, the first row, the second column. So I have 1 times 0 plus 7 plus 2 times 7. The last one to 2, so I take the second column, the second row and the second column. I have 3 times 0 plus 4 times 7, and consequently finally I have the following matrix. And 5 plus 12, 17, 0 plus 14, 14, 15 plus 24, it is 39, and the last one 28. By the way, if you replace A and B and put them B times A you can have the same matrix C. You can check this statement. Also, one small example and the last conclusion. Example. For example, A equal 1, 2, 3, 4, 5, 6, and B equal minus 1, 2, 3, 1, for example. No, you can notice that this matrix is 2 by 3 matrix, and this is 2 by 2 matrix. So, if you try to calculate A times B matrix, it is a known one. You can firstly check the size of these matrices. It is 2 by 3, 2 by 2. You can notice the external number, they are not equal, so it is impossible to calculate. Impossible. So sometimes it is possible to calculate the product of matrices, but at the same time, B times A, 2 by 2 matrix, and 2 by 3, it is possible, and your matrix C has size 2 by 3, so you have 2 and 3 here, and we have equality of the external numbers. So it is possible. And we have minus 1, 2, 3, 1 times 1, 2, 3, 4, 5, 6. And as a result of this multiplication, you have 2 by 3 matrix. C1, 1, C1, 2, C1, 3, C2, 1, C2, 1, C2, 2, and C2, 3. Well, for example, if you calculate C22, I put here separately, you have to take the second column, the second row, and we have to move along the row and along the column and multiply elements correspondingly. So 3 times 2 plus 1 times 5, and you have 6 plus 5, 11. Okay, this is the example. So you can notice here that product of the matrices is not a commutative operation. So it means that usually A times B is not equal to B times A. But for square matrices, the square matrix is matrix when the number of columns equal to the number of rows. So it's n by n matrix. For example, 2 by 2, 1 by 1, 10 by 10 for square matrices. A times B equal B times A. It's enough for today, and you have your special home assignment. Good luck.